Hello, this is an illustrated presentation for the pathophysiology of ARDS. Let's start with a brief review of the normal histologic structure of the alveolo-capillary interface. Here we can see an alveolus and a capillary, and in between lies the interstitium. Two types of epithelial cells line the alveolar wall, that are type 1 cells and type 2 cells, which is responsible for surfactant production. The capillary wall is lined by endothelial cells. Two basement membranes are found in the alveolo-capillary interface, that are the alveolar basement membrane and the capillary basement membrane. This layer in yellow represents the surfactants. The pathophysiology of ARDS runs through two successive stages, that are the exudative stage and the proliferative stage. These two stages can be further subdivided into four progressive and overlapping stages, that are the stage of edema, the stage of hyaline membrane formation, the stage of interstitial inflammation, and the stage of interstitial fibrosis. Generally speaking, the pathophysiology of ARDS can be represented by the word DAD, which represents diffuse alveolar damage. It's also of importance to know that the exudative stage is a stage of inflammation, while the proliferative stage is a stage of repair and fibrosis. Now let's start with the edema stage. This stage is characterized by thickened capillary endothelial lining, capillary congestion, and regarding capillary basement membrane, there will be widening of the intercellular junctions and disruption and denudation of the basement membrane. All these changes of proteinaceous fluid from the capillaries into the interstitium and into the alveoli through both denudated and disrupted basement membranes of both the alveoli and capillaries. Finally, the result will be both alveolar edema and interstitial edema. The second stage in the pathophysiologic process of the exudative stage is the stage of hyaline membrane formation. This hyaline membrane is formed of plasma proteins and fibrin. The plasma proteins results from leakage through disrupted alveolo-capillary membrane, while the fibrin is derived from intra-alveolar activation of coagulation, which is an effect regulated and mediated by the mediators release. These mediators are released from the neutrophils, which migrate from the intravascular sites through capillaries into the interstitial space and into the alveoli through the disrupted basement membranes. The proliferative stage is a stage of healing and fibrosis, as we mentioned, and this stage starts 7 to 10 days after the initial injury and starts with the stage of interstitial inflammation. In the proliferative stage, the characteristic features are cellular proliferation, disordered healing of the inflammatory process, and this will finally result in extensive pulmonary fibrosis as we progress to the fibrotic stage. In the stage of interstitial inflammation, there will be more numerous inflammatory cells within the lung interstitium. Also, we will find necrosis of type 1 epithelial cells with the progression of the disease. The final stage in the process of pathophysiology of ARDS is the fibrotic stage or stage of fibrosis. With progression of the disease and after 2 to 4 weeks from the initial injury, there will be alveolar fibrosis resulting in fibrotic septa and collapsed non-compliant alveoli. Also, there will be interstitial fibrosis and the capillaries become thrombosed and they are now not fit for gas exchange. Now let's summarize this pathophysiologic cascade, which starts with direct or indirect lung injury, leading to mediator release that affects both the alveolar epithelial cells and the capillary endothelial cells. The effect of mediators on alveolar epithelial cells results in shift in fluid and proteins to the inside of the alveoli, leading to damage of both type 1 and type 2 epithelial cells. Damage of type 1 cells will result in thickened alveolar capillary membrane and impaired gas diffusion, while damage to type 2 cells will result in decrease in surfactant production and increase in surface tension of the alveoli and decreasing their compliance. The overall result will be alveolar collapse. Also, the effect on endothelial cells will result in increased capillary permeability and pulmonary vasoconstriction. The increasing capillary permeability will cause interstitial pulmonary edema, and the pulmonary vasoconstrictor effect will result in alteration in regional blood flow. The overall result also will be alveolar collapse, leading to ventilation perfusion mismatch and increase in the work of breathing with intrapulmonary shunting, and the final result will be hypoxemia that is refractory to supplemental oxygen.